Hello, we are Peace of Mind Engineering. I'm Rachel Horner, and I'm accompanied by Owen Dale, Alex Chris, and Chase Malinowski. Our project was to structurally design a four-story hotel in Boston, Massachusetts. Our design procedure was to start by calculating the loads. We first found the dead, live, and snow loads, and later found the wind and seismic loads. We then calculated our members, which included the columns, beams, girders, and joists. Last, we finalized our design. For our governing equation, we found that equation 3 in ASC 716 controlled with a 1.6 snow load.
For the wind loads, we used the maximum speed of the wind from the ASC hazard tool and wind maps to determine and the height of the building to determine the load on each floor of the building and found that floor four controlled. And we determined this for both the winds coming into the long side of the building and into the short edge of the building. And then for the seismic loads, we used the weight of the building to determine the in the ASC seismic category to determine the loads, and we used the governing equation from ASC 716.
This is the bay we identified as a controlling bay for our design. The girder in this bay spans 18 feet, making it the longest girder in our system, and therefore it experiences the greatest bending and load effects. The joists in this bay are spaced at 6 feet on center, which is wider than the 5-foot spacing used in other bays. This increased spacing results in larger tributary areas and higher loads being transferred to each joist and ultimately to the girder. For our floor system, we selected a 1.5 VL 22 gauge composite deck system paired with a 3.5-inch concrete slab. This combination provides sufficient strength and stiffness while maintaining efficiency in material use. The system is supported by W12 by 26 joists and W16 by 31 girders, which are designed to safely carry the applied loads and transfer them to the vertical structural elements. These members are connected to an HSS 3 by 3 by 1/4 column, which provide the necessary support and stability for the structure. To ensure full composite action between the steel framing and concrete slab, each joist and girder is equipped with 22 shear studs that are 3 inches long and 3/4 inches in diameter. And these studs play a critical role in enabling the steel and concrete to act together as a single unit, improving overall strength, stiffness, and load distribution.
Our building will use a combination of rigid and flexible diaphragms to resist lateral loads on the building. The rigid diaphragm will resist loads for each floor, and the flexible will resist loads on the roof. For the rigid diaphragms, the controlling load is on the fourth floor. In the north-south direction, we will use six 22-foot 4-inch 5 by 5 by 5/16 single angles in the elevator shaft and stairwell. In the east-west direction, we will have four 18-foot 4 by 4 by 1/4 single angles placed symmetrically in the walls to help reduce any eccentricity that could take place. For the flexible diaphragms, we will use 36.5 with one number 10 screw per side lap. It will be supported by a 16K6 joist that is spaced 2 foot 6 inches on center. Thank you.